A sequence is an ordered list of numbers, and there's a whole bunch of information in this notes packet that honestly you don't really need. The important thing is talking about an infinite versus a finite sequence. So here's an example of a finite sequence, 2, 4, 6, 8. There are 4 numbers in that sequence. Those numbers are 2, 4, 6, 8. An infinite sequence, 2, 4, 6, 8, dot, dot, dot. Does anybody know what the dot, dot, dot is actually called? An ellipses. High five. Okay, so an infinite sequence has some sort of a pattern and it continues on and on and on and on. A sequence can be specified by an equation or a rule. For example, both of the sequences above can be described by this rule. A sub n equals 2n. So this thing says A sub n equals 2 times n. A sub n is a symbol that means the nth term. So the nth term is 2 times n. So if I wanted to find the 12th term, I could do 2 times 12. If I wanted to find the 200th term, I would do 2 times 200. So the n is which term we're talking about. And the domain is the number of the term. So the domain of this finite sequence is 1, 2, 3, 4 because there's term 1, the second term, the third term, and the fourth term. The range is the actual terms in the sequence, like 2, 4, 6, and 8. Not that you really need to know that all that much, but yeah, it's there. So first I want to get you familiar with the symbols and how to write the terms of a sequence based upon the rule. So this sequence is defined by the nth term equals 5 times n minus 1. So the first term is going to be 5 times 1 minus 1, which would be 4. A sub 2, the second term, would be 5 times 2 minus 1. So notice, whichever term number we're using, that's what we plug in place of n. This would be 9. A sub 4 would be 5 times 4 minus 1. And if you're noticing the pattern, you might actually be able to finish out this sequence without doing the math. You're just adding 5 each time. And think about this. Does this kind of look like y equals mx plus b? So 5 is kind of like the slope, so it makes sense that we're adding 5 to get each term. Now once we have those 5 terms, we need to write it as a sequence. So 4, 9, 14, and so on, dot, dot, dot. All right, try number 2 on your own. The weird thing about number 2 is that they use f of n instead of a sub n. A sub n and f of n mean the same thing. So the first term would be f of 1, and you're plugging 1 in for n. So take a moment and find the first 5 terms by plugging in the numbers 1 through 5. This sequence doesn't have quite the easy pattern that the other one has because there's that exponent, but the sequence should be -1, 1, 5, 13, 29, dot, dot, dot. Number 3 is a little bit weird because it gives this to you as a fraction. So our first term is going to be 1 over 1 plus 1. 1 plus 1 is 2. Your second term will be 2 over 2 plus 1. 2 plus 1 is 3. Do you see how the denominator is 1 more than the numerator? And the numerator matches the term number. So really, you don't even have to do the math on this one. The first term is 1/2. The second term is 2 over 3. Third term is 3 over 4, and so on. So if you do the first and second term and you really see the pattern and you know that pattern is going to continue, don't bother with all the math, just do the pattern. So there's two specific types of sequences that we are going to be working with. Those two types of sequences are called arithmetic, if I can get my highlighter, and geometric. I know it looks like arithmetic, but when you're talking about sequences, it's called an arithmetic sequence. An arithmetic sequence deals with addition and subtraction. A geometric sequence deals with multiplication and division. So, if you are adding and subtracting by the same amount each time, it is an arithmetic sequence. So it says down here, an arithmetic sequence, the difference of consecutive terms is constant. So basically, if you are adding or subtracting the same number each time. To get from one term to the next, you're adding or subtracting the same number each time. And that number that you're adding or subtracting is called the common difference. We use the letter D to represent the common difference. So, in these three examples, we need to decide, is this an arithmetic sequence, yes or no, and explain our reasoning. So, number 1, how would you get from 2 to 5? Add 3. Can we do plus 3 to get from 5 to 8? And then plus 3 to get to 11? And then plus 3 to get to 14. Do you see how it's adding 3 every single time? So yes, this is an arithmetic sequence because we have a common difference of 3. If you take each term and subtract the term before it, you will get 3 every single time. Try number 2 and 3 on your own. Number 2, yes, it's an arithmetic sequence because the common difference is -6. Number 3, did you guys see that it is not an arithmetic sequence? It's decreasing by 4, then decreasing by 2, then decreasing by 1. Or if you look at it, what's it actually doing to go from? It's dividing by 2. So for your reasoning, you could say no D, like no common difference. Or for your reasoning, you could say it's a division rule. And that makes it not an arithmetic sequence. Okay, now to the good stuff. We are going to use a formula to write a rule for an arithmetic sequence. Here's the formula. A sub n means the nth term, a sub 1 means the first term, and d is the common difference. Go to the next page. We're going to write this at the top of the next page. In order to write a rule for the arithmetic sequence, you really need to know the first term and the common difference. The a sub n just has to go there, and the n minus 1 has to go there. So, in this first example, a sub 1 is 3. The first term is 3. What is the common difference? Look through that sequence. What is the common difference? To go from 3 to 8, we're adding 5. Are we adding 5 on all of them? Yes. So our D is 5, and I'm going to highlight that with blue. So a sub n equals, we need to write our first term. So what's our first term? 3 plus parentheses n minus 1. And then we need to multiply by our common difference, D, which is 5. Now we're just going to do some pretty simple math. When you see parentheses with a number, what do you usually do with that number in those parentheses? You distribute. So this is kind of like backwards distribution, but that's okay. So we have 3 plus 5 times n is 5n. 5 times -1 is -5. Combine your like terms. So our rule, a sub n equals -2 plus 5n. Pretty easy. Then it says to find a sub 15. How do you suppose we find a sub 15? You plug 15 in place of the n. A sub 15 is -2 plus 5 times 15. And honestly, on your assignment, plug that into your calculator. -2 plus 5 times 15. Let's see, what is that? 75, 73? I would like you to try number 2 on your own. We're probably going to skip number 3 if you do okay on number 2. All right, let's move on to the next example. The problem on the next example is that they don't give us all of the information that we need. They're telling us that the 19th term is 48, and the common difference is 3. So I'm going to start by writing the formula. A sub n equals a sub 1 plus n minus 1 times d. So here's what we're going to do. I'm going to put 48 in place of a sub n. Now when I do that, which term is 48? It's a sub 19. 48 is the 19th term. So I'm going to use 19 in place of my n. And I do know that my common difference is 3. So I want you to see how I used the 48 and the 19 in that problem. Because 48 is the 19th term, we use 19 in place of n. Now we're going to do as much of the math as we can and see if we can figure out a sub 1. So this would be 48 equals a sub 1 plus 18 times 3. 18 times 3 is 54. How could I figure out a sub 1? Subtract. This is the annoying part. Now we have the first term and we have our common difference. So now we need to go back and do what we did before. Our first term is -6. Our common difference is 3. We need to distribute, combine like terms to get our final rule. The point of this problem is to write a rule for the nth term. The problem is we don't have everything we need to do that, so we have to do some extra stuff to get a sub 1 and then go back and do the whole process. So -6 plus 3n minus 3, -9 plus 3n.